Girls, welcome back to my laboratory. Today I want to talk to you a little bit about chemical changes. But before we get started, I want to make sure that if you are at home and you try to duplicate any of my demonstrations, you always need to get your permission from your mom or dad and make sure they're there. Make sure you have a grown-up around. Safety first. Okay? On to chemical changes. Chemical changes. What's a chemical change? Well, a chemical change is when you take two substances, you combine them to form a completely new type of matter, or they're combined to break matter down into its more simpler ingredients. Chemical changes always involve the use of energy. It either brings in or consumes energy or releases it in the form of heat, light, or electricity. Today I'm going to go over some really good demonstrations that involve chemical changes. Not every chemical change happens super fast. You don't combine the two substances and get voila, a new item. Some chemical changes happen really, really slow and take a lot of time. And for this video I started an experiment a couple of days ago. It's been going on for about 4 days, and I got this idea from our textbook, and it's taking copper and creating copper acetate. So here's what I did. I went out and I found the shiniest penny that I could find. It's a lot like that one right here. This is a 2014 penny. It's as shiny as I could find. The next thing I did is I took a dab of glue and a piece, this is just a piece of paper plate. I took a dab of glue and I glued the penny to the paper plate so that one side of it would be completely exposed. I went and I got a little bit of vinegar because copper acetate is created from copper being exposed to fumes and vinegar. Put vinegar in this cup and then I just set the paper on the cup. And the fumes came up. It hit the copper and it created a completely new substance called copper acetate. This took about 4 days to happen, and I really didn't notice any release or consumption of energy whatsoever. I just sort of set it there, checked it each day, make sure it was working, and voila, what I got is that shiny new penny turned into this green thing that looks a lot like the Statue of Liberty. Right here. Now, it's not hard, it's not metallic like a penny, that caught the green substance. It's not a fume or wet like the vinegar, it's completely new. It actually feels very waxy, almost like a crown. So there's a slower reaction where I combined vinegar fumes with copper to get that green waxy substance called copper acetate. Very slow reaction. Now, I'm going to keep this going. I'll bring it into class and show it to you next time I see you. It'll be pretty cool. That's an example of two substances coming together. A chemical reaction or chemical change happens and a totally new substance is formed. Another example of two substances coming together, being broken down, I have right here for you, is this marshmallow. Now, think about a marshmallow. What is a marshmallow? Well, it is a tasty treat that you make s'mores with over your campfire, but to a scientist, what this marshmallow would be, it'd be almost like a sugary blob. Well, what's sugar? What are the basic components of sugar? I hope some of you remember that. Sugar is what? Hydrogen, carbon, oxygen. Good. It's hydrogen, carbon, and oxygen combined in the right forms, the right circumstances create sugar. And when I combine those in the right circumstances, I get this marshmallow. So, to a Cub Scout, I got a marshmallow. To a scientist, I got a sugary blob. I'm going to introduce this sugar to some heat. By heating this sugar up, or this marshmallow, now what's going to happen is this marshmallow is going to burn. You're burning your s'more. What's really happening is the water vapor is being released. So your water is hydrogen and oxygen. The hydrogen and oxygen is being released. What does that leave behind? Just carbon. So my once tasty marshmallow is now a carbony disaster. And if you can see, you take a good look at that all the way around, because science is about observation. I burned that one edge. And I just going to take my finger right here, and I'm going to knock that off. And what I have left on my plate, that's carbon. That's what carbon looks like. So, with the penny, I created new matter. With the marshmallow, I broke matter down into its more simple components. That's a chemical change. And also, this is a neat one. Make sure you must have a grown-up. If you're going to burn a marshmallow, you must have a grown-up around. Okay? Please do not do this one. When the grown-up's there, you can burn your marshmallow and look at the carbon, and then you can eat the marshmallow, but you gotta have a grown-up. Carbon. That chemical change
That's a good marshmallow.
happened really a lot faster than the copper acetate. The next demonstration I want to go show you is I got this idea from one of my friends. He did a science fair project called Too Much Gas. And he mixed two substances together in different amounts. He measured them out and mixed them together. He was looking for the right combination of ingredients to create a gas, carbon dioxide. Now, I'm not really looking at combinations as he did in his science fair project. I am more interested in the gas and what's happening around it. So here's what I did. I got this 2-liter bottle right here. It's a nice container. It holds a good amount of substance. And I emptied it out. And inside the bottom, what you'll find is baking soda. Now, baking soda to anyone else it's the thing that you stick in your refrigerator to help keep the smells out, or you use in baking. I'm not doing either one of those. Its scientific name is sodium bicarbonate. And that right here, I got some sodium bicarbonate in the bottom of my container. The next ingredient that I'm going to use is my vinegar again. And for those of you who have ever done the exploding volcanoes, know that when you mix your vinegar with your sodium bicarbonate, it almost gives like an eruption that comes out. Okay? And that's a chemical change occurring. But I want to capture the matter left behind in the chemical change. So, I took the top of this 2-liter bottle and I poked some holes in it and I attached a balloon. Right here, there's a balloon. There's nothing in this balloon. It's kind of flat. There's nothing really in it. So I've got that and I have the balloon attached. I'm going to pour the vinegar into the bottle. You're going to see some crazy reaction occur, and hopefully, I did this before, but hopefully it works again. This balloon is going to fill up with a gas. That gas is the new matter that I am creating, the new substance. So I'm going to pour it. I'm filming. I'm going to pour it over the sink, and then I'll show it to you on the video.
Okay, I'll just walk through.
Okay, right here, vinegar and baking soda creating some carbon dioxide, hopefully. Now, what you're seeing is the chemical reaction happening, and there's my balloon. It's beginning to fill up. But what I am feeling on the bottle is it's getting super cold. Cold like a refrigerator. Yeah, and that is the heat that's being consumed. Every chemical reaction involves energy. This one's using heat energy to create carbon dioxide. It's sucking the heat out of the air in the bottle and surrounding to use it in its chemical reaction to create this gas right here. Now, I could put more in and I could fill this balloon fuller, but you want to be careful because it happens really fast and you get lots of fizzing, and I didn't want to go all over the place. But in my balloon right here, I have carbon dioxide. This is a chemical reaction that happens fast. I can see its energy being used. I can see the new matter, or I can see the new matter inflating a balloon. It's a really good example. Remember, this is something you need to do with a grown-up, okay? Do it with a grown-up. So, I got some good examples of creating new matter, breaking matter down into its simplest parts, I hope you've enjoyed these demonstrations. Let's just review. A chemical change is combining two substances to form a new kind of matter, or combining two substances and breaking matter down into its simplest components. Chemical changes always use up energy in the form of heat, light, or electricity, or release. They consume or release the energy in heat, light, or electricity. Okay? Good luck on your quiz.